Okay, I'm on page 81 of Axler's Pre-Calculus book, version 2. This is section 1.3, and I want to talk about problem 43. Let me see if I can't bring up the picture here. Consider this graph f of x goes through 1, 1, 3, 1, and 5, 3 is shown, and it asks us, okay, now find the domain of g of x, the range of g, and the sketch, the graph of g. Okay, and we're going to do 43, where g of x is equal to 2, that's a vertical stretch, of f of, notice that here we have a horizontal stretch and a shift left. So I took the liberty of sketching that out on a piece of paper. Okay, so notice here it's pretty easy to see that the domain of f of x is 1 to 5 inclusive, and the range is 1 to 3. How do I get the range of g of x? Well, notice that in order for this to be a valid input, the input here has to be between 1 and 5. That's an input that goes into f. So really what I have to have for the domain is I have to have the input make sense between 1 and 5. So I have to have this input make sense between 1 and 5. If that is between 1 and 5, this will make sense. Now, what does this say about x itself? Well, we have to subtract 1 from both sides. Then I have to multiply everything by 2. Notice I've subtracted 1 from all 3 terms. Now multiply by 2. So the domain for g is 0 to 8, including the endpoints. Okay? So if I got ready to sketch my graph, I'm going to be wanting to make sure that I go from 0 up to 8. Okay, how about the range? Well, notice what's happening to the outputs here. So the outputs that this can produce are between 1 and 3. Okay, so this output is going to be between 1 and 3, so I'm going to look at this just a little bit differently. I'm going to say the output, any output of this is between 1 and 3. This is going to stretch it vertically, so I'm going to multiply the whole thing times 2. If there was a vertical shift, I would add whatever the vertical shift was to it. So this now becomes 2 to 6. That's the range. So somehow or other, I'm going to be between 2, 4, 6. 2, 4, 6. Okay, so I know that I'm going 0 to 8. I know that I'm going 2 to 6. Now, what exactly is happening here? Well, what happens when you plug 0 into g? Think about this. G of 0 equals 2 times f of 0 over 2 plus 1. That's 2 of f of 1. Notice f of 1, that's the smallest input in the domain here, so that makes sense. F of 1, according to this graph, is 1. So this is 2 times 1, or 2. Right? So that's the point. Now, that kind of makes sense that this is at the lower left hand of the domain. Another way to think of this is that this got moved to this interval. Okay? So this piece got stretched to that interval, and this 2 stretched it twice as high, right? So the dot was at 1, now it's at 2. This dot was at 3, now it's at 6. This dot that's halfway across your domain was at 1, now it's going to be at 2, right? Because everything is getting doubled. This was at height 2, now it's going to be at 4. So my graph's going to be like that. Okay. Now, you can check as many points as you want to sort of get yourself comfortable with that. Okay, so g of 4 equals 2 f of 4 over 2 plus 1, which is 2 of f of 3. F of 3, right, is 1, so that's 2 times 1, which is 2. So g of 4 is 2. So this should make sense in terms of the graph, in terms of what you know this does to the graph, but it also should make sense in terms of the equation. You could plug in g of 8, get 6, g of 2, get 4. If you wanted to, you could plug in parts in between and get those same values. Hope that helps.